calculator? You figured that one out, right? Function, parametric, polar, sequence mode. So we get the n's to appear by just hitting the X button, but the problem is we don't want an n. Not for Fibonacci. What do you guys think n-min stands for? N-min. N1. I don't know what N1 is. What is N1? If you guys want, you're like, wait, but we used K's. We can change this to be N's if you want. It doesn't matter to make it look like the calculator. So we need A sub N equals N minus 1, N minus 2, where N is greater than or equal to 3. Carl, where's your calculator? Okay, then go ahead and stop just messing around. Notes should be open. Thank you. Pencil should be out and ready. You should be looking at Joseph's calculator. Thank you. Okay, so, what variables are different? U's and V's and W's. What is U representative of in R's? A. I heard it. It was very quiet. Do you guys get that U is A? U of N is like our A of N, right? And the of, this is just like notation, right? U is a function of N just like A is a function of N. Okay. So if R said U of N is equal to U of N minus 1 and, sorry, I just gave the answer. If R says A sub N is equal to A sub N minus 1 and A sub N minus 2, I don't want to put A's in here. I want to put U's in here. Okay, so where's a U? Where's a little u? I mean alpha, but those are capitals, aren't they? Capital A, capital B, capital C, capital D. I don't want capital U. I want a little u. Anybody find a little u? Yeah, 7. Second 7. Do you see him? No. Second 7. Try hitting the buttons and see if you now agree. Second 7. Do we have U's? And the answer is yes. Now hold on. Wait. How do we do subscript? How are they doing subscript? Second 7 is a U. Not called brackets, but you're close. Parentheses. How did they show a subscript here? With function notation, right? So they showed the subscript with function notation. We're just problem solving, kiddos. So how are we going to do a subscript of N minus 1? Parenthesis, N minus 1, right? Oh, well, this isn't as bad as we thought, maybe. So you guys keep going with the formula because there's another part to the formula, right? But we're not doing A, we're not doing a subscript, we're doing, You good if I keep on typing then? Second 7 of N minus 2. Okay, you got to think about the notation. N min, you might have been a little confused about, but now look, U of N min. We know what min means in math. Min must mean minimum. What's the minimum N? Wait, what does N even stand for in sequences and series? The term. If N is 1, first term, N is 2, second term, N is 3, third term, right? Okay, so N min, what's the lowest N will be? Technically 1. Technically 1, right? So if N can be 1, because Fibonacci, we need to have the 1 and the 1 first. We can't go straight to the third term. If N min, if the lowest term is going to be the first term, right? Not the negative first term or the negative 10th term or anything else. If the first term is first, then what is U of 1? Wait. What is U of 1 going to be? Come on, you have to connect this to that. Yes. Why is U of 1, 1? What is another way of saying u of 1? A sub 1. A subscript 1. U of 1 is the same thing as saying A subscript 1. Same thing as saying, oh, who's the first term? So much easier if they'd say that, but they're doing the notation. Who's the first? Well, what's the first term, guys? Oh. Okay, so let's go ahead and just try to go to our table and say, okay, did it work? Ha-ha. Oh. Go to. What's wrong? Do you see where mine went to? Where did mine go to? The last part. It doesn't like that. Well, why doesn't it like that? Fibonacci doesn't start with one term. Fibonacci starts with, ooh. So what if we were to say, we need to start with, I'll give you a second. Anybody have an idea of how to show starting with 2 terms? Not slash, that's division. A good idea, though. Keep thinking. Not division, though. Maybe, except they're using braces instead. What? Comma. Separates items in a list, right? Huh. Now, you could be like, oh, where's the brace? It's technically second parenthesis. Or you could have just hit enter. I think it would have filled it in. Now let's go see. Uh-oh. What's wrong with my table? There's only one. It looks like one that maybe I typed in at some point in time. How do I change my table setup? Second window, good. What do I want to change it to? Automatic instead of ask, good. And if you want, you could try to change the start, but you could just be like, whatever, is it working? And then if it is, we'll scroll back to where we want. Is it working? 1, 1, 2, 3, 5, 8, 13. Huh. Why is this cool? If I was to ask you for the 50th term in the Fibonacci sequence, what would you have had? What would you have had to have done? Whew, let's go. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 2. It's not horrible. It's addition, right? But some of you are like, Now what can you do? Scroll down. Oh, come on. You guys are better than that. Or what else can you do? Can't you go down and then just go to ask and just say, oh, hey, you know what? What's going on at 50, please? Oh, cool. What's going on at 27? Oh, cool. How quickly does it take the calculator to literally do 1 plus 1 is 2, and 2 plus 1 is 3, and 3 plus 2 is 5, and 5 plus 3 is 8? Did you see how long it took? Now, if we do something like 500, is it going to be thinking for a little bit? Yeah. And it might even say something called overflow, because the number might be too big for it to even show you. Interesting. But it did get there fairly quickly still. Huh. Oh, I have to change my table setup to be ask. And then you can just type in whatever you want. If it's automatic, are you allowed to skip? Can you type in stuff? I don't think you can, right? Right, 27? Yeah, no. It's a good try. I wish you could. Okay. We might come back to this, but do you guys at least get the idea of how the calculator can do recursive formulas? Okay. Are those the only kind of formulas it can do? No. Do you guys remember yesterday there was that one, the n squared minus 1, 1, that some of you guys found the pattern and some of you didn't and waited till we got the formula? Can you go back really quickly? Can you get the n squared minus 1, which is technically an easier sequence? Can you get that in your table? Take out Fibonacci unless you want to keep them in there for, I don't know, prosperity's sake. Otherwise, take out Fibonacci. And I want you to try to get the sequence in there from yesterday, the n squared minus 1 sequence. the n squared minus 1 sequence. And as you guys do that, I will try to get the air to turn off. Okay, it should be turning off any moment. Get the n squared minus 1 series. What was that series? 0. This guy. 0, 3, 8, 15, 24. Get this guy in there. He should be easier, but maybe he's harder since I showed you the hard one first. You guys got it? All right, what'd you guys put in your calculator? Beep, beep. What'd you guys do? What'd you guys do? Oh, you just put in n squared minus 1? Oh, that's easy. Okay. So this type of formula is way easier than the recursive one, huh? Okay. What's your u of n min? It's not 1. 0. N starts at 1. First term, n starts at 1. But u of 1, remember, what's that talking about? U of 1 is a sub 1, and a sub 1 is the first term. And what's the first term? 0. So once you get the first term in there, then go ahead and go check out and say, dun-dun-dun, go team. 0, 3, 8, 15, 24, 35, 48, etc. Is that cool? Oh.
We got the same exact answer.
How'd you get it?
We didn't do the top one. We did 1 as the first spot.
So this one's missing the 0?
I think so.
Does it start at 3?
It starts out, yeah.
Well, it'll end up the same, except Colby, is your 3 attached to 1 or is it attached to 2?
Oh, no, we still have a 0.
Oh. Well, no. I agree. My first n is 1, just my u of n min is 0.
No, we put it 1 for the middle one.
Oh, you did? Interesting. So you can be wrong whenever you have an n squared formula? Well, that's good to know. You can be wrong whenever there's an n squared formula. But guess when you can't be wrong? When there's a recursive formula, you can't be wrong. So this is probably there just in case you're doing a recursively defined formula, because recursively you have to know where you start from. For instance, if I was to do something like, actually we'll use it today in class, I'll try to show you why that little u of n min is super important for recursive formulas. But I guess Colby just figured out, I mean, you could probably change it to 5 or 10 or 15 or 20, and it should all be the same, I think, if you guys want to check it. But I guess you can be wrong if it's an n squared or an nth term formula. Because to generate this sequence, it's not looking at previous terms, it's looking at the formula itself. So interesting. I know the programming was like that. Okay, we played around with our sequence mode. Is there anything else in this section? No, we already talked about that, already talked about that, already talked about that. Fibonacci. Ooh, last thing. At the end of homework, you might have gotten a little bit stuck on something with factorials. Well, what's a factorial? N! Not quite. When you see an explanation point in math, what is it almost always referring to? Either a very exciting word problem or a factorial. 0! No. Although my dramatic ones, you can have fun with this. But what's a factorial? Commonly, because it's very loud. You're like, ah. It's okay, it'll wake them up. Isn't it like the Vine with like all the batteries? Anyway. No? The AA, the AAA, the... There you go. What? I have no idea. Katrina sent me this compilation last night, and I was literally like, or she was listening to it when she was doing a math lab, and I was like, what on earth sent it to me? I'm like, I don't find any of these funny. There was like one with like a guy who was trying to shovel snow, and he was like slipping and sliding. That was funny. The rest of them, I'm like, I just don't get it. Her compilation was interesting. I didn't think it was very entertaining. Oh, shock. Okay. I laughed at like 3 out of like 25. Anyway. It's okay. Yeah. All right. Most people have remembered factorials or have learned factorials. How many of you guys recognize a factorial? Oh, go team. Okay. Factorials. So if I was literally, oh man, I could have had so much fun with this. So if I was to just write this down, you just would have been like 4, right? That's so sad. Okay. What is 4 with what we would call, maybe I should do this now. This is called a factorial. You would think it has the word factor in it, that somehow you're factoring something, and it's totally wrong. Nothing to do with factoring. I mean, the word must have come from somewhere. I haven't really researched it. Great thing for you to research tonight when you're online being not so productive. 4 factorial. Most people memorize it to be 4 times 3 times 2 times 1. Starting at the number that you were at and counting down. The dilemma is we are going to see factorial expressions that don't count down but instead need to count up. So I'm going to change just a little bit. Technically, guys, is it the exact same thing? And the answer is yes. However, in order to write it this way, don't you have to know what the number is in the factorial to know where to start? This way, whatever, start at 1. Go how far? I don't know, till it's time to stop. Okay. But anyway, long story short, factorials. What does 4 factorial end up equaling however you write it? 24. Good. What's 2 factorial? 2. What's 3 factorial? What's 5 factorial? 120. What did he do? 24, 4 factorial, times 5. 120. What would 6 factorial be? 120, 5 factorial times 6, right? What would 7 factorial be? 50-40? 50-40. All right, anyway. The most common ones that like are good to have memorized is 6 factorial and below. The other ones just kind of start to get a little tedious. Now, have you guys written down n factorial? Does it make sense now? N with the word factorial. Okay, it means n with a little exclamation point in math. Hey, is this exclamation point in your calculator? Where's all the cool mathy stuff?
Oh, that's in second math.
The math? Second math. Don't go second math.
Isn't it in complex? No, it's in.
Did you guys not do any probability last year?
We did probability.
Okay. Some of the probability should have had factorials in it.
We didn't do probability.
Permutations, combinations have factorials. Anyway, where's the exclamation point? If I said something about probability. Math over to probability, and then number 4. There's an exclamation point. That means repeated multiplication. Now, guys, here's the weird one that we kind of need to memorize. It's kind of similar. I like to think like anything to the 0 power. Well, any non-zero number to the 0 power. What's any non-zero number to the 0 power equal? Why? Why? Most of you have just memorized it, right? We'll be honest. But couldn't you use something like, hey, x to the 5 over x to the 5? What's x to the 5 over x to the 5 equal? 1, right? We know they reduce to be 1. But exponent rules, don't they say we can subtract the exponents? Okay, so what's 5 minus 5? X to the 0 is really just x to the same power, top and bottom, so yes, it will always equal 1. Anyway, even though there is a reason as to why, most of us just memorize it. Guess what most of us are going to do with this guy if we are smart? Make sure you know it, and if you can't understand why, then memorize it. There is a reason why, but sadly, it always takes me a little bit to figure it out. And I have a way for the and I get so maybe I'll figure it out for tomorrow. No, because factorials don't include 0. Hence the dilemma. If you think about the factorial definition, starting at running up, you don't. It has something to do with kind of this idea. The 5 minus 5 gets to 0, and then like you don't necessarily look at the 0, you look at where it comes from. I just don't remember off the top of my head. I should have had it ready and I didn't. But kiddos, here's the dilemma. There's a button in your calculator that will help you get to any numeric factorial, 4 factorial, 20 factorial, 17 factorial. That's a huge number, P.S. But what do we do when there are variables? First of all, are these the same thing? What would you say?
No.
Why not? So you have to do the parentheses and then the factorial. This one you wouldn't have to do the parentheses. Then what difference does that make then, Colby?
One's a vertical translation, one's a horizontal.
Yeah, except n factorial is not going to be a function. So I don't like it's going to just be lots of points that basically get really high really fast. Really high really fast. Like way faster than exponential growth. So I don't necessarily know if I want you guys thinking about like graph transformations at all. Does that make sense? Because it's like points, not like a continuous curve. Let's just forget the whole graph idea. What's the difference? Where do they both start?
The first one you're multiplying them all at once.
Well, yes. Except here's the dilemma. You said them all, and technically that's not right. Where do they both start? Yeah, if we think about starting at 1 and counting up, don't they both start at 1? They're both going to start at 1. And they're going to count up, right? Okay, this is a dot, dot, dot for I don't know who n is, so I can't tell you exactly where it stops. Where can I say this one stops? No. Plug in something. Plug in 3. 6 factorial. Wouldn't that just be 1, 2, 3, 4, 5, 6? Plug in 10. 20. Wouldn't that be 1, 2, 3, 20? Plug in 15. 30. Wouldn't that be 1, 2, 3, 30? Where do you stop at? Whatever it is. Right? Ryan.
So, 2n would be, like without the parentheses, would be 2 times the result of whatever n is.
Nicely done.
The one with the parentheses would be 2 times whatever n is, and then that would be the result.
So, Ryan has seen it. Let's see if the rest of you can follow it. 2n, you would find that number first, then 1, and then stop at 2n. Did you hear what he said about the first? My question is, when does your factorial end? At n, and then you multiply that by 2. Which, Colby, I had to stop it with what you were saying, because you were saying multiply everybody by, but there's no distribution going on. Does that make sense? It's just one value times 2. One value doubled. Or you could say this plus itself. You could say like it's twice. And then this one, I think you were thinking like 2, 4, 6, but since this only shows the stopping point, it doesn't affect any of the earlier ones. You were thinking series, and we'll get there, but a little different. So here's my question. Who's bigger or stronger, the top one or the bottom one? Does it? Let's assume a very large value of n. A very large value of n. 50. We'll use 50. Who's stronger?
Bottom. Because it goes to 100. So.
Do you see the difference? Some of you got there and some of you are still wondering. We understand this one more, so then we'll answer this one quicker. And you kind of just heard it. Most of you, if you gave an answer real fast, you said the top one. I just said n was 50. So numbers 1 through 50, right? Numbers 1 through 50 times 2. This one be. So who's stronger, 1 to 50 and then a 2? Or 1 to 50 and then 59 to 100? All multiplied together. 2 is a lot weaker than 59 to 100. Does that kind of make sense? Or 51. I don't know, because I randomly went to 59. 51 to 100. Because you would go from 1 to 50, you would go the same amount as this guy, but then you would go a whole heck of a lot more. It would be times 51, times 52, times 53, times 54, a lot more than times 2. Okay, so what if I was to give you, this guy? What if a sub n was written in, kind of introducing some Calc BC stuff, well, how to read the given information for Calc BC? Eileen's back there being like, anyway. Write the first 5 terms of the sequence given by, beginning with n equals 0. Oh, well, remember yesterday I said n could start at 0 or 1. Okay, fine. N starts at 0. Plug it in, plug it in. I don't know if you want to. It's not that bad, is it? They're all tied together. Don't worry, I'm just setting up the terms. I'm not going to give them to you right away. You guys have to think about them. Wait a minute, though. It said n needed to start where? Good. So my first 5 terms aren't going to go up to 5. What are my first 5 terms going to go up to? 4. Did you guys get it? How do I get my first term, aka my a sub 0? Yeah, plug what in? Good. 2 to the 0. I don't know, we'll get there. All over 0 factorial. What do I do for a sub 1? Oh, that's not bad. Now I just need to simplify it, right? And some of you were trying to simplify at the same time. That's not bad. What is 2 to the 0? What's 0 factorial? Nice. What's 1 over 1? Got it. 2 to the 1. 2. 1 factorial. 1. Wait, so 0 factorial and 1 factorial are the same thing? Yes. 2 to the 1, 2. 2 over 1 is? 2 squared is? 4 over 2? Because 2 times 1. 4 over 2 is? Oh, that's a weird sequence. 1, 2, 2. 8 over 6? 16 over 24? Question. What if I wanted you to find the, oh, that'd be too mean. 7th term. What if I didn't just stop with write the first 5 terms? What if that was just part A to a problem, and then I was to say, hey, by the way, part B, find the 7th term? What would A be subscripted with? Nope. Yes. Careful, right? Because the 5th term had n equals, does that make sense? So the 7th term would be a sub 6. So what would my formula be? 2 to the 6 all over 6 factorial. Now pause. Some of you are really good at mental math. You're like, I know 2 to the 6 real fast. I know 6 factorial really fast. For a lot of us, possibly, that's a lot of math, yeah? So we do something like 6, 4 times 3 times 2 times 1. You're like, why are you doing that? Well, couldn't I say something like 2 to the 6th? Easier. Couldn't I make that 4 times 4? What? Why did I change that? Isn't 4 2 squared? 2 squared, 2 squared? Made it a little bit easier. Can't I say, oh, the 4's cancel? Oh. Can't I say that? Oh, now it gets a little rough. Maybe it would have been a little easier if I'd done my 2's, right? Because if I had done my 2's instead, couldn't I have then canceled out a 2? Then couldn't I have 6 with an 3? Dun, 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 dun. There are lots of numbers inside of factorial that you can reduce with, even if you can't get the whole number right away to begin with. Does that kind of make sense? Some of you I know could have done 64 over 100, nope, 720. Yeah, 64 over 720 and tried to reduce, but some of you, you're like, I'll stick with the little numbers. They look more fun. So what do we do there without a calculator? Ooh. How do you reduce 8 factorial over 5 factorial without a calculator? 8 times 7 times 6. How do you get there so fast? No. Because 8, 7, 6, 5 factorial. If you're counting backwards, you can get 5 factorial pretty quickly. 8 times 7 times 6 times 5, 4, 3, 2, 1. Over 5, 4, 3, 2, 1. Oh. Just 8 times 7 times 6, right? Now, or a little bit. Think a little bit more to get there. We could do 8 times 42, which would just be 336. Anyway. Did my brain jump there? No, I'm not that kind of brain. I wish I was. It'd be fun sometimes. I did a baby column multiplication. And I thought of a little 8, and I was like, oh, 16, carry the 1, 33. Anyway. Some people's brain jumps straight to the answer, and that's really cool. Just mine didn't. And most of yours wouldn't either. Most. Maybe not all. Letter B. What do we do? Question, who's going to be stronger or bigger? Hi. Who's going to be stronger or bigger? Yes, the bottom one is bigger because the bottom one says, hey, I'll go all the way to n. Top one doesn't go so high. Still might go high, but it doesn't go. I'm just putting lots of dots and I don't even know what I'm doing anymore. Dot, 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 times n minus 2, right? So I think I can cancel out some things. Huh. Question, guys. Who would have been right place? In its, the previous term. n minus 1. What would have been before n minus 1? So couldn't I do this, and then do this, and then do this, and then say, oh, all of those go away. And I'm left with 1 over times n minus 1, or for n minus 1 times n? It is. Oh, come on. You're seeing it for the first time. Why are we talking about the test? This is still section 9.1. You weenies. All right. Huh. N minus 3. And n minus 4. And n minus 5. Because these count by ones. So if this was 10, 10 minus 1, 9 would have come before. 10 minus 2, 8 would have come before. 10 minus 3, 7 would have come before. 10 minus 4, 6 would have come before. Does that make sense? Whoo! Sigma. Oh my goodness. We're having too much fun in section 9.1. We're not going to 9.2 today. Here we go. Boop, boop. Sigma notation. You guys have seen sigma before. Be careful with that. So, sigma notation. Remember? This sigma gives you where to start plugging in and where to end plugging in. And you plug in only whole numbers, counting numbers. Like we've been talking about, n is the entire time. So the sum of the terms of a finite sequence, a1 plus a2 plus a3 plus a4, we can summarize that whole blah, 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 blah into this nice little short, sweet notation. And say, hey, a sigma denotes repeated addition of terms that follow a certain formula or a certain pattern. Of terms that follow a certain formula or a certain pattern. Now, for some reason, I grossly underestimated how much stuff we had to do today. So therefore, keep writing. We're going to get to the next page before class. But then whatever we don't finish as far as you guys are going to copy down, because I'm going to end, and it's going to be saved online. So whichever one's easier for you to find. Whatever notes we don't finish in 9.1, you are going to take, and I'm going to also put the first page of 9.2, and that's what you need to have done tomorrow, as well as homework fully attempted for 9.1. Come with questions, but homework fully attempted for 9.1. Oh my goodness, taking notes will take you like what, 5 minutes? You're fine. No. Oh, you want to see how to write a sigma? That one's fun. You do like a backward C, put a little tail on it, bring it up, and then just top it off. It's okay, you'll be practicing when you're doodling in history today. Never mind. Bible today. Nah, pay attention in that one. English today. You know what? If you're brainstorming, just start doing sigmas. Okay, there are different properties with sigmas. We're not going to have to necessarily memorize tons and tons. It's more of an understanding of how to make things a little bit easier. We could put C in every single term or just pull them out in the very, very front. We could add all these terms together, then put them up, or we could do all the A terms and all the B terms and just put them all together. Anyway, there are some properties that have to do with it. But guys, as I said, we're not going to finish, sadly, all the notes we need to for today. We had a little too much fun with stuff with our calculators, which is a good thing. We're going to use it. But we did not get to write down everything I wanted as far as notes. So I'm going to go ahead right now. Oh, you guys should be able to do that, though. You've seen these before. I'll go ahead and show 4 online for you guys to go ahead and mark down how many lines we need to skip. Ooh, this will be fun. There's an infinity on top. Dun, dun, dun. Oh, then we're done. But I'm also going to put up section 9.2, the first page. Boop. So you guys know what notes you're supposed to take tonight? Yes. Have them all ready for tomorrow? Yes. Fully attempt. Oh, guys, how do we do these? No. There's a pattern. All you got to do is just add. And what do you plug in? Well, you start at the lower bound, and you keep counting by ones until you reach the... Oh. So it's 1 3, 2 3s, 3 3s, 6 3s, 10 3s, 15 3s. It's really just 45? Wait. 3, 6, 10, 15. Yeah, 15 3s. Bye, guys. Fix the desk, and then you may leave. Hope you're okay.